My name is Zac Sweers. I work on a bunch of open source stuff like Ketchup or Moshi or Autodispose. I'm currently fun employed and working on moving to New York, which I realize is a technically fancy way of saying homeless and unemployed. And I'm learning some things about New York while I'm here, like the exotic pronunciations of words like Houston and Stuyvesant. And I hope you'll learn something here too. So quick feel for the audience here. Who uses Dagger? All right, that's basically everyone. 1, 2, anyone use Coin? I won't tell Jake. All right, Juice? Anyone here not use DI in any form? I like how you got to tap on the shoulder just to remind you to raise for that. So fear not. So for anyone who doesn't use Dagger 2, some of these work in other DI patterns too. Dagger just makes it easier. So back to the talk. Today I'm going to be talking about some Dagger party tricks, specifically 4-ish of them. These aren't meant to be like weird trivia or gotchas or anything, but rather just clever and neat ways that you can use Dagger to enable better patterns in your code. So the first thing I want to talk about is, leading on a strong foot here, is something that I think you can take home and do today. It's really simple and straightforward. When I gave this talk a few months back, I posted this to Twitter and basically, letting people know I was going to do it. And perhaps not surprisingly, it turned into a bit of a guessing game from some people. So some of the asks were good, like that fast init or using lazy or static providers. One of these is on the right track for this. Some of these were on other tracks, like make everything make everything serializable and load at startup, or kill the process on startup. So they're clever, but these aren't what I'm getting at. The solution that I am talking about, though, is clever, but it's nothing fancy. So who here uses retrofit? All right, who doesn't? All right, keep your hands up. Anyone that sees them, befriend them and show them the light. So here's the same 3 lines of retrofit that everyone pastes into their app. It's pretty vanilla retrofit, and somewhere later you'll pass in an RX call adapter or your Moshi converter. But for now, we're just going to focus on the pretty basic stuff here. So chances are you're plumbing in your OKCDP client here. And again, pretty standard. Farther up the chain, we'll have other provides for the client, such as its cache. And there you go, your standard square buffet. So who's basically got this in their app? All right, cool. So who does this at startup? All right, I'm seeing a lot of shaky hands, like Queen's Wave here. So that's around what I thought. Most people are doing this on startup because you got to start, if you log analytics when someone opens your app, then you're doing this. So let's look at this a bit in context though. So on app startup, our DI graph is going to roughly follow this path, where our cache is going to get initialized, then we're going to go to OKCDP, and then finally we're going to feed that into retrofit. All this gets injected somewhere, say a constructor of our imaginary class here. Now here's the kicker. This step can take 100 to 150 milliseconds to fully start up, because you've got a lot going on here. Like in OKCDP, there's this trust manager factory that on some devices can take 100 milliseconds in the wild. Whenever you're providing your cache up here, this... I thought I had a laser pointer for a second. That was cool. Whenever you're creating your cache, you're actually having to go look up the cache directory here. It used to be eagerly initialized in OKCDP as well, which would then involve some disk I/O. And even now, it still spins up its own executor during initialization. And you're paying all this cost up front for something that is ultimately not needed maybe on startup, or at the very least going to be on a background thread every time you use it. So what can we do here? And the answer is lazy. Lazy is a concept in Dagger that you've probably seen or even used. But if we look at our example here, where can we use this? The trivial answer is we could just apply it at the injection site. And this kind of works, but you're just kicking the can down the road a bit, because as soon as you use it, then boom, you hit that cost again. Potentially on the main thread or wherever you're calling it from. There's another way there, though. So you see this client, retrofit speaks OKCDP, and that's nothing new. What you might not realize, though, is that this is actually just a shorthand for another method called call factory. Now, call factory is an interface in OKCDP that OKCDP client is just an implementer of. And anything else can implement this, or you can also just do plain simple delegation. So more simply, since it's just a single method interface, we can put it in a Lambda. Now we're cooking with fire. So the entire client is actually just being wrapped up and deferred in this. And what that means is that we can actually take this client and make it lazy. And this is actually everything that we need for this example. Now we deferred the entire initialization of the client to the first network call. Now here's the kicker. What thread is that called on? Hopefully not the main thread. So if you're using something like RxJava or coroutines and doing your network call off the main thread, then that means that this entire thing, there we go. Stop it. Okay, so this entire thing is now paid off of the main thread. And it's also amortized by whatever the cost of your I.O. is. So if you're doing a network request, that could be 300, 400 milliseconds. If you're in India, that could be like 10 minutes. The 100 milliseconds that you were paying on startup, you've now actually kicked to whoever's waiting for this network request. And taking all of those and batching them into a network call, you're saving yourself a lot of time here. And in short, you've taken all of this and kicked it off to a background thread. And if you want to be super, super sure that you're actually getting the behavior that you expect, you could even stick some main thread checks in there. So switching gears, let's talk about modularization. So modularization is a great way to decouple dependencies, improve build times. With Dagger, I've got a couple of tips for modularizing easily. First, let's take a look at refactoring. So say I've got this giant module, only 2 here, but imagine that there's like 50. It's full of seasoning and taco provisions. So say I want to refactor this a bit. Either I want it to be smaller or I want to reuse some bits of it. A common pattern that I see people do is do something like this, where you're pulling it out from the top and you leave everything else in this sort of base module that exists sort of in perpetuity. I usually think this is actually the wrong thing to do, though, because when you do this, then you have to update usages for everyone to point to your new dependency. Now, everything you pull out of base is just going to depend on base anyway, so no one's really getting any benefit of it. But it's on the right path, though. It's the right spirit. But we can make a couple tweaks to this approach, and I think that you'll end up with something better. So let's look at this again, but instead of making a base module and pulling stuff out from the top, let's think of it a different way, and let's pull things out from the bottom. So in this case, let's say pull seasoning out to its own module that my giant module depends on. This looks quite similar, but the key difference here is that anyone depending on my giant module didn't have to do anything. Your API for consumers of that hasn't changed. You can continue iterating on this and refactoring it under the hood. It's all just an implementation detail of how it's composed. So this makes refactoring dead simple. You can iterate on this without churning people. You can take more steps along the way. Now at this point, my giant module is actually completely empty and it's just a shim in front of the other modules. You can keep iterating and tweaking things too to your heart's content, and then maybe at the end of this, you're finally able to just drop my module or my giant module entirely. This part is a breaking change, but you've basically done all of the churny changes under the hood well before you got there. So this you can just do in one atomic change and you're done. If you want, you can even also give consumers of this, say you're working on like a library team or platform team where other people are using this and you want to let them migrate at their own cadence, you can just deprecate it and then you have all of the replacement pieces ready for them to use. Even better though, if you're using constructor injection, you don't need any of this. In fact, if you're doing constructor injection with these two, then all you need to do for your modules is that. You don't have to write any modules for this because Dagger can just construct them for you. This brings another interesting point for modularization, though, that's worth mentioning. What if these are separate projects? So say when we compile feature A here, if we have no prior code gen done, then Dagger is going to generate a taco factory class. This is what Dagger uses in CodeGen to construct it and link dependencies into it. Now, if we use this in feature B, the same thing is going to happen. Now, if I'm consuming both of these features in my app somewhere down the line, what's going to happen here is we're going to actually have a class path conflict between these two, because Dagger compiled or generated both of them. You're trying to use them both later, and the compiler is going to look at you and be like, something's a bit weird here. So how can we solve this? And the solution here is pretty simple. You just run the Dagger compiler over the food subproject as well, where this lives, and Dagger will just generate the factory there instead. Now in later versions, so in feature A and feature B, Dagger will actually recognize that this class was already generated and just reuse the same instance for everyone. It's cool. On to the next tip. Let's talk about internal and private APIs. This one is pretty quick. So let's look back at that food module. Right now, anyone who wants to include this module are going to get seasoning as a dependency if they wanted to as well. But say I wanted to make seasoning a private implementation detail of the taco, but I still want to use a separate provider. So we can use qualifiers in Dagger and the compiler to do this for us. Now, this time when I say compiler, I mean the actual Java compiler or Kotlin compiler. So writing a qualifier is easy. We'll just call it internal API. Now to use this, the trick here is to just make it private. So in Kotlin, you can just put this in the same file as the top level class that you're using it in. In Java, you can just put this as an inner class of the module that you're using it in. And then you just take this annotation, drop it in on the dependency you want to make private, and now, boom, like seasoning is no longer accessible outside of this module because no one outside of this class can actually even use that annotation. So they can't ask for it, even if they want to. And so that's a sort of roundabout way of letting the compiler do work for you and guarding your dependencies. The last area that I want to cover is multi-bindings. So these are ostensibly the coolest and most powerful tools here, and they're also very open-ended into what you can do with them. They're pretty standard in DI, so Juice, Dagger 1, Dagger 2 all had them, and the core components of them are maps and sets. So a quick refresher, set is corresponding to annotations like add into set, add in elements into set. Map is corresponding to things like add into map and add map key. You can declare it up front, and it basically just collects multiple instances of a given type that you can then use in bulk later. So let's look at our food module again. The same as before, we have seasoning in a taco. But what if our taco accepts multiple seasonings, as most tacos should? We have a couple of types here. So we've got spicy seasoning, Old El Paso seasoning. But we've lost a little bit of our DI principle here, though. The taco provider at the bottom here knows quite a bit about the seasonings coming into it. And this is where multi-bindings will really shine. We can just accept a set and provide into a set. So we declare the set up here, and then we just annotate these providers with add into set. And then at the bottom here, we just accept a set of seasonings. And Dagger's going to piece all this information together. This also allows other modules to contribute into a set. So if I want to pull these seasonings out to another module, this will still work fine. And this is where things become really powerful. Anywhere where you're contributing multiple instances of something can leverage this kind of tool. So this is a trivial case, but say real-world cases where you have pluggable APIs. So OKHTTP and its interceptors, or Mashi and JSON adapters, or Timber and logging trees, or more advanced cases, you could gate entire features behind this in a DI-friendly way. So let's make this a map. And yeah, this, there it is, yeah. So in our screen here, we've got different categories for pets. We've got dogs and cats and birds. I'm not totally convinced that cats count as pets because they're more like little tigers in your house. Say you want to wrap them all up in this sort of category-based API. Now, what if you want to make them lazily initialized? Well, in Dagger, you can just wrap it up in lazy, and Dagger will just natively understand this and wrap them all in lazy for you. You can also do them with a provider to guarantee new instances, and no other changes are required. Dagger's going to do all this for you under the hood. It's zero overhead to do this. Well, zero source overhead. So you could even implement an entire app behind a plugin system backed by this. So this is a side project app of mine on GitHub called Ketchup, and each of those tabs is actually added in a multi-binding. So this main pager actually knows nothing about these individual services. It just gets a mapped multi-binding coming into it, and then unwraps those services and creates new instances for each of these tabs. In these maps, you can just have keys added in here as metadata for the service, so like the ID. Some of these bits are trivial, but what if you wanted to, say, do experimentation flagging? It's actually really easy with this. You add this, say, experimentation ID, and then just filter at your injection site for whichever ones are enabled, and then you drop the ones that aren't ready yet. And that's it. These are some of the examples that inspired a lot of this. This blog post here is a longer write-up of that plugin system that I was just describing with my side project app. Yeah, I hope you learned something, and if there's any questions, I'll be hanging out here on the side after. Thanks.